In this note, we will examine how firms do capital budgeting. Most firms have a process for soliciting capital projects. Some firms solicit capital project proposals once a year. Others have a continuous process. However, one of the biggest challenges all firms face is how to determine which of the capital projects get funded. Do you fund a $5 million equipment replacement proposal, a proposal for a new product, new production facilities? Confronted with a set of choices, firms need a process for evaluating projects. Underlying everything as we go forward is the key assumption that a firm's objective is to maximize shareholder value. Given this assumption, the most commonly used ways of evaluating investments are net present value, or NPV, and internal rate of return. Both of these produce decisions which are consistent with maximizing shareholder value. Net present value, or NPV, takes cash flows and discounts them at the appropriate risk-adjusted discount rate to arrive at a value for the project. This is the estimate of the value of the project to investors. Once we have this, we deduct the cost of the project, and the difference is the NPV. The NPV decision rule is, if NPV is greater than 0, accept the project. If NPV is equal to 0, the firm should be indifferent, and the firm can either accept or reject the project. If NPV is less than 0, the firm should reject the project. Let's look at an example. A project has the following cash flows. We discount these cash flows using the appropriate risk-adjusted discount rate. In this case, we assume an 11% discount rate. Then each cash flow is discounted. First cash flow of $350 is discounted one period at 11%. The second is 2 periods at 11%, and so on. The last cash flow is discounted 11% for 5 periods. The sum of all the present values is the value of the project. If the cost is $1,200, then the difference between the value of the project, $1,415.10, and the cost of $1,200 is a net present value of $215.10. The NPV of this project is positive, and the project is acceptable from a value creation point of view. The internal rate of return, or IRR, of a project is the discount rate that will discount the cash flows back to a value equal to the cost of the project. It is the rate of return that investors will earn on the project, given the cost and the cash flows. The IRR decision rule is, if the project IRR is greater than the hurdle rate, accept the project. If the project IRR is equal to the hurdle rate, then the firm should be indifferent. If the project IRR is less than the hurdle rate, the project should be rejected. Now let's calculate the IRR for the same project. Here we set things up a bit differently. We have the same cash flows in years 1 through 5, and the initial outlay in year 0 is $1,200. We need to find the discount rate that will discount the cash flows back to a value of $1,200. We can use a trial and error process or one of the Excel functions we use with bonds to find the IRR. Here a rate of 17.66% will discount the cash flows back to a value of $1,200. As such, this is the internal rate of return. Since IRR is greater than 11%, the project is acceptable. For the remainder of this discussion, we will focus primarily on NPV, and in order to evaluate projects using NPV, we need an estimate of cash flows and an appropriate risk-adjusted discount rate. It is important that the way we estimate cash flows and our choice of discount rate be consistent. The choice of how to measure cash flows and estimate the discount rate reflects how the project is financed and how the firm is organized. First, firms usually separate the operating functions and the finance functions. In addition, projects are financed from a pool of funds, not individually. Hence, we need measures of cash flow and risk-adjusted discount rates which reflect these characteristics. Let's look at how firms fund projects. Typically, a firm has a pool of funds that is financed with some combination of debt and equity. All projects are funded out of this pool of funds. This means that projects do not have individual financing specifically for the project. Hence, we can establish a rate of return for the pool of funds and use that rate as the hurdle rate for projects that are funded from this pool of funds. In fact, this is just the concept underlying weighted average cost of capital. In addition, if we are using a hurdle rate that incorporates both debt and equity, we need to use a cash flow definition that includes payments available to both debt and equity holders. This is how we define free cash flow. Weighted average cost of capital and free cash flows are perfectly matched and are consistent with the way firms fund projects. In addition, since the free cash flows reflect only operating flows and WACC reflects the financing flows, the separation of operations and financing also is consistent with the way most firms are organized. Hence, we find most firms use free cash flows and weighted average cost of capital in the NPV analysis. Let's look at this process in a bit more detail.